In this video, we are going to be learning all about algebraic equations. Now, in a previous video, we talked about algebraic expressions, and if you remember, we said that algebraic expressions were like a mathematical phrase. Well, algebraic equations are like a mathematical sentence, so it's the full idea or the full thing. So let's jump into, first of all, what is algebra? Okay, so algebra is the language we use to notate and solve for unknown values. So algebra is the language we use to notate and solve for unknown values. Okay, so I want you to think of equations being like a scale. Equations are like a scale. So that's what we have here, a little balance scale, where we have everything on one side balances with everything on the other side. Now, you'll see that in scales like this, we would have, if there is more weight on one side than the other, it would tip like this or like that. In an algebraic equation, our balance scale is always going to be equal. So they're perfectly in balance. If one were to be out of balance with the other, heavier or lighter, then it would tilt, and this would then become an inequality, greater than or less than. But in equations, it's always going to be equal. So imagine, if you will, we have some objects on our scale. So what if we were to have a red square here, and we were to have 5 red little squares over here? Okay, and then we also had over here some triangles. Okay, but we just have 2 little blue triangles. I'll go ahead and highlight this here so that our definition of algebra stands out a bit. Okay, so in this model, the red squares represent known values that are constant. It is a known value that is constant, whereas the triangles are going to represent unknown values that vary, or that could be different from problem to problem or equation to equation. All right, so we can take this idea of these 2 triangles and a red cube perfectly balancing with these 5 red cubes, this idea that they are the same, or they have the same value, and we can put it into an algebraic equation. So I can say we have 2 triangles, or 2 unknown values. Now the unknown values is, I'm just going to call it an x. And we know that we have 2 of them. And we're going to call this x. It is the variable. The 2 is a special mathematical term that we call the coefficient. Now, the coefficient just means the number of variables that you have, or the multiplier. Okay, so it is a multiplier. So this would mean 2 times x. And if the coefficient were 3, it would mean 3 times x. If the coefficient were 1/2, it would be 1/2 times x, which is equivalent to x divided by 2. So it's just the way that the coefficient multiplies that variable, which again is the unknown value. Now, what else do we also have on this side of the balance scale? We also have 1 red square. Now we know that that 1 red square is just a known value that's constant. So we're just going to use a regular number 1. So there's 1 cube over there. That value is constant, so it is called a constant. That is the vocabulary term. a constant. So any just random number in an algebraic equation without any variables connected to it is called a constant. And then what do we have? It's equal to, which means we flip over to the other side of our balance scale. And how many constants do we have, or how many red cubes? 1, 2, 3, 4, 5. 5. So that also is an example of a constant. So we have 2x plus 1 equals 5. And this here, my friends, is an example of an algebraic equation. Now, we can solve for these unknown values, or this x, or this variable. To solve for any unknown values, or to solve for unknown values, no, that's grammatically incorrect. Use a set of logical rules centered around the concept of balance. Okay, so balance. Algebraic equations and all of the logical rules that you're going to learn in algebra are centered around the idea of balance. Okay, so what do I mean by that? Those logical rules. Okay, well, let's just think logically. If two triangles and one red cube is in perfect balance with 5 red cubes, let me make this actually cube-shaped, square-shaped. I'm using the 3-dimensional term, but I mean square in this context. Then we know that one triangle, what is that going to equal? So this red cube balances with this red cube, and then 2 of these triangles. So that means if I were to substitute that in, each one of these triangles is equal to 2 of these red squares. They are in perfect balance. So in algebraic language, that just means x is equal to 2. And there you have it. That, my friends, is algebra.